Hey gang, STAT1800. The purpose of this video, and I want to go ahead and apologize for the crappy lighting. I'm working at home today, and there's really just not a lot of places to hang out and put up a video. So anyway, the purpose of this video is to introduce you to the concept, at least the techniques for constructing a confidence interval for beta 1, which now we should know that that's the slope. So guys, again, as a review, we have our sample data that's collected from a larger population. And this stuff over here is called a statistic, and this stuff over here is called a parameter. And much like we use X bar to estimate mu, we use B0, which is the intercept, to estimate the population intercept. And we use B1 to estimate the population slope. Now, let's focus on if we were wanting to take X bar and estimate mu. And use a confidence interval to do that. What we would do, and let's just assume that sigma is not known. Then what we would do is we would take X bar, which is called our point estimate, and we would add and subtract margin of error. Now, in previous videos, back when this stuff was much simpler than it is now, we saw that if the population standard deviation isn't known, that we would be modeled by a t-distribution, so we would have a t-critical, and that the margin of error would be the sample standard deviation divided by the square root of n. And the t degrees of freedom would be n minus 1. So guys, moving that into this new stuff, calculating a confidence interval for beta 1, it should make sense that instead of using X bar, we would use the sample slope. But we would still add and subtract margin of error. The million-dollar question is, what does this margin of error over here look like? Well, guys, we should, from using the test statistic for hypothesis testing, we learned a lot about that. Turns out it still uses the t-distribution, so the t-critical that we're going to use, again, comes from the t-distribution. And guys, in this case, instead of degrees of freedom being n minus 1, the degrees of freedom is n minus 2. Now, but the million-dollar question is, what does the standard error look like? And the value that goes here is just the standard error for B1. So guys, in previous videos, I showed you that the standard error for B1 is, well, that's supposed to be an x, SYX over the square root of the sum of squares for x. Okay? Now, it turns out that we luck out a little bit on this. So I tell you what, let's just jump into a problem, an example. I kind of like this example with the redwood trees. So, if we're going to actually calculate the diameter of breast height to calculate the height of a tree, what we would do is we go to regression, simple linear regression. Our x variable is diameter at breast height, and then we're trying to predict the tree. Even though the purpose of this video is to concentrate on the confidence intervals, let's just look at the hypothesis test first. So we compute that, and we see right here that our estimate, our B1, is 2.673, so I'm going to write that. The next thing that we need is we need our t-critical. So guys, I can go to calculator, go to t. I'm going to use between. I have the sample size of 21, so my degrees of freedom are 21 minus 2. and I want the area between these two values to be 0.95. So plus or minus 2.093 is going to be my T critical. Now, that's not the way that I've demonstrated it in previous videos. In previous videos, I'd say, well, let's put the area in the right tail to be half of our alpha value, which in this case, if we're a 95% confidence interval, we have a type 1 error rate, an alpha value of 0.05. So half of that 0.05 goes in the upper tail. And you can see I get 2.093, the same thing. So either way we do it, we get the same thing, which is good. Kind of wacky if it didn't work that way. Now, next thing I kind of like that's kind of cool is the estimate of the error standard deviation. Guys, that's that SYX that we need. So I can put 24.747 in the place of, and let me go over here and show you, in the place of my SYX. Now guys, that's really written kind of sloppily. Is sloppily a word? If it's not, it should be. All right. But so the next thing we need to do is we need to get this sum of squares for x. And guys, if you remember, I'd say you probably don't, but if you look back in your notes, SSX is just the sum from I equal 1 to n, which in this case is 21, of our x values minus the mean quantity squared. And I want to run through that with you on StatCrunch, just to show you how we can build a formula. We've done this before, but I just want to show you how we can easily do that. So, guys, I can go to data and go to compute and go to expression, and let's build. So I want left parentheses, and I want my x value, which is the diameter at breast height, minus the mean of my x's, and I want the height to go there, and then I want to square that. So I build a function very, very easily in StatCrunch. So I've got these values, and just check, I need the, oh shoot, I did it wrong. Guys, that's embarrassing. Compute, expression, build. I need the, no, that's right. The x is diameter of breast, right? Yeah. But no, I did do it wrong. I need the diameter of breast minus the mean of diameter of breast. Guys, I'm losing my mind. I got too much going on. All right, let's see what's going on here. So, okay, I need a parentheses right there. All right, that's much, much, much better. This one is absolutely useless. So this, I need to come in and do sum. So I need the second one, which is the correct one. Sometimes I think making errors is good, but it's more so, I think, when it's in class, just to see if people are paying attention. I could be really clever here and tell you I did that on purpose, but I didn't. I just messed up. All right, I've written that over there. So that value, we take the square root, okay? So guys, grab your calculator, and I'll tell you what, my calculator's been giving me a hard time lately, so we'll see if it works. So I have 2.673 minus, I'm going to put this all in parentheses, 2.093 times 24.74 divided by the square root of 4,376.285. So I hit enter, and I get 1.89. Can y'all even see that? Yeah, I think they got a little bit better. Then I'm going to go with second entry, and all I'm going to do is come up and change this negative to a plus. So my confidence interval ranges from 1.89 to 3.46. Now, what does that tell me? It tells me it's a 0.95 probability that that interval contains what I'm looking for, beta 1. Now, guys, if you want a confidence interval, if you need a confidence interval on your homework assignment, I don't encourage you to go through all this this math using this, writing all this out. I encourage you to just get the confidence interval. You might say, well, why didn't you just show us at the beginning? Well, the reason I didn't show you about that in the beginning is you're stuck with a statistics professor that thinks that liberally educated people should know more than just how to use technology. So simple linear, we're going to take diameter of breast height to predict the height of the tree. And I want to do a confidence interval, 0.95. Really, just for the confidence interval, we don't need much else. But we can go compute. And guys, you'll see that you have the lower limit, 1.89, and the upper limit is 3.46. Guys, can't make it hard if I tried. So StatCrunch kind of takes all the fun out of it, but so good for you. Guys, that's all I got. Take care.